Hi, this is Alex from devstories.eu. Snowflake and Snowpark Python, episode 15 of 17. Moving terabytes of secure data out to an external machine learning server is slow, expensive, and risky. You spend hours pushing data across the network, and your security team gets nervous about where it lands. What if the compute came to the data instead? This is the core idea behind training ML models inside Snowflake. By leveraging Snowpark Python, you can train single-node machine learning models directly inside your data warehouse using stored procedures. The data never leaves the Snowflake perimeter. This solves the data gravity problem. Instead of extracting millions of rows to a separate cloud instance, you execute your training script right where the data currently lives. Training a machine learning model requires loading the dataset into memory. A standard virtual warehouse in Snowflake is optimized for parallel SQL queries, not for holding massive datasets in system RAM. If you try to fit a complex algorithm on a standard warehouse, you will likely hit out-of-memory errors and the process will crash. To handle this, you need a different compute profile. Snowflake provides Snowpark-optimized warehouses specifically for this task. These warehouses provide up to 16 times more memory per node compared to standard instances. Let us walk through a concrete scenario. You need to train a scikit-learn random forest model on a huge customer dataset. You start by writing a Python stored procedure. When you register this procedure, you specify the required Python packages such as scikit-learn, pandas, and joblib. Snowflake automatically provisions these dependencies using its integrated Anaconda channel. You also assign the procedure to run on your Snowpark-optimized warehouse. Inside the procedure, you use the Snowpark session object to define your training data query. You then call the method to convert that Snowpark data frame into a standard pandas data frame. This action pulls the query results directly into the physical memory of the warehouse node. Because you provisioned the optimized compute, there's plenty of RAM to hold the entire dataset at once. Next, you initialize your random forest model and invoke the fit method, passing in the pandas data frame. The warehouse processor handles the training cycle exactly as it would on a dedicated machine learning server. Once the model finishes training, you have a fitted algorithm sitting in the temporary memory of the execution environment. You must persist it for future predictions before the stored procedure finishes. This is where serialization comes in. You use a library like joblib to package the model. You take the trained model object in memory and dump it into a file, creating an artifact. You then instruct the stored procedure to write that newly created file directly to an internal Snowflake account. A stage acts as a secure storage folder tied to your Snowflake account. Here's the key insight. Your stored procedure acts as a secure container connecting your raw tables to standard Python machine learning libraries. By keeping the pipeline entirely within Snowflake, you drop your network latency to 0, bypass all data egress operations, and maintain strict access controls, all while writing the exact same Python training code you already know. That's all for this one. Thanks for listening, and keep building.